Hi everyone, welcome to today's math final brought to you by me, Tyler. Today we're going to be talking about L'Hopital's rule. So, if you don't already understand the concepts of limits and derivatives, then this video probably isn't for you because you need both of those in order to understand and complete the rule. So, without further ado, let's get right into it. So, let's start up with a warm-up because I want to show you guys something. So you see this is a normal limit, and since it's just 3x squared over 2x plus 4, you know the limit is x approaches 5 of this function. What we're going to do is we're going to plug in 5 because there's no issue. You just go to 3 to the 5th, 3 times 5 squared, over 2 times 5 plus 4. And then that's your answer, that's the limit. And as you see, you just get a normal number for the answer. It's just a basic constant, 75 over 14. Okay, so since we're in semester 2 now, we already have a clear understanding that sometimes the limit does not exist. It may equal 0 or it may equal plus or minus infinity. But while these are all determinate forms of a limit solution, there are times where the limit may procure something known as indeterminate form, which isn't even legitimately a solution because we don't know what it equals. And with limits that are set up in the format where there's a function over the function, we can procure things such as 0 over 0 or plus or minus infinity over plus or minus infinity. And these are not legitimate responses, so we have to use L'Hopital's rule to find out what the actual limit is. With L'Hopital's rule, we take the derivative of the top function and the derivative of the bottom function to see if the limit is something that can be found in a determinate form. So now we have an example function, the limit as x approaches pi over 2 of cosine of x over sine x minus 1. And let's put the sine x in parentheses to clarify. First thing we're going to want to do is break this up. A key to both understanding L'Hopital's rule and having the ability to justify it is being able to analyze the top and bottom limits. So finding the separate limits to prove indeterminate form is what we're going to do. It's also important to prove the separate limits because you can't write out that the limit would be equal to something that is 0 over 0 or infinity over infinity. So to show that it's indeterminate form, you're going to want to do the separate limits to show that there's 0 on the numerator because cosine of pi over 2 is 0, and that there's 0 on the denominator because sine of pi over 2 is 1, and then 1 minus 1 is 0 as well. So now I'm sure you're wondering, what's the next step? Written in simple terms in the top left-hand corner, that if the limit as x approaches a procures indeterminate form, then the new limit, which is equal to the old one, is that of the derivatives top over bottom of each function, and that will hopefully give us a solution. So what we're going to do now is, you see the old limit here on the left, it is the limit as x approaches pi over 2 of cosine x over sine x minus 1. And now, just as the rule at the top, which is L'Hopital's rule, states, we are going to first find the derivatives of the top and the bottom and go from there. The derivative of the numerator, cosine x, is equal to negative sine x, this we know, and the derivative of cosine x, or the derivative, of sine x minus 1, the original denominator, is just cosine x, because derivative of all constants is 0. And so now what we're going to do is we're going to plug in pi over 2. We find that negative sine of pi over 2 equals negative 1. And on the denominator, the cosine of pi over 2 is 0. So this limit does not exist. Sorry, I got cut off there. But as I was saying, this limit does not exist because it is negative 1 over 0, and that produces a response that we know. We've had limits that do not exist before, and that is technically a determinant form. So there we go, there's an example of L'Hopital's rule. This audio is choppier than a fresh salad. So, as your tutor for this lesson, I want to set the record straight. Not every time you do L'Hopital's rule, you'll get the answer on the first try. Sometimes you take the derivative of the top and bottom functions and you get another indeterminate form answer. So then, what you've got to do is you just recreate the limit and take the derivatives again, and if that works out, hopefully you have a determinate form solution. I also want to clarify that the quotient rule is not the same thing as L'Hopital's rule. L'Hopital's rule uses the derivatives to find the limit as x approaches something, and the quotient rule uses derivatives of the top, is used to take the derivative of functions that are written top over bottom or like in a division form. Yep. I should have done the whole video like this.